Welcome back. Now let us learn the time series forecasting. This is one of the very important topic, and I have seen the use of this topic almost every organization where the forecasting happen on the time series. So let's start. There have been the research almost more than 100 years in the time series forecasting, and I have seen there is a lot of the things. Probably you have heard a lot of the model and all. So definitely when there is a research every year, there is a new model comes, the new technique comes and so on, which people like. And if some of the models work for the few years, the new model will come and so on. So that is why I will also show you almost 5-10 models, and definitely there are 20-25 models that have been invented in last many years, and they were right at their own time. But it may happen that as we start getting more and more new data or complex data, we tend to when that model does not work, so we tend to invent a bit more. So that is what it has happened. So one of the latest models which have been working right now, I have seen this working in production for many of the organizations, and I myself have used in the product in many projects. So this is called ARIMA. AR is autoregressive and MA is moving average. R is basic identity, and also this denotes the differences. Okay. So for this first part, it has two parts. ARIMA, the first part that is denoted in a small PDQ, it is a non-seasonal part, and the capital PDQ is a seasonal part, and M is the seasonality. So this is the notation of this ARIMA. And how does this really start? So there is a multiple steps for the ARIMA, and I'll explain. There are two ways to do it. One is the manual way, this is the left side. One is the automated way. Okay. So how does it start? Whenever you have the data with you, please plot it and see if there is any anomaly, missing data, or anything bad. Just try to correct those. It may require you have to do the box-Cox transformation to stabilize the variance. It means it is a very high variant, or any other transformation. Then do it. Basically, this is step 1 and 2 is the exploration part and correction, and in data preparation for the time series. Once you have the really good data which you can use for the forecasting, then the model building comes. Let me explain the first manual part, and then I'll go ahead and make it for the automated part. Okay. So in case of manual part, once your data is really clean and ready to go ahead. Okay. Then first of all, you have to make the time series stationary. So that we can make it by differentiation. So once you take the difference, basically try to lag 1, 2 and make a difference. I have seen, as per my experience, after taking lag 1 and 2, it becomes stationary. So that is good. Then plot ACF and PSF and try to see what is the value of PDQ and so on. Then you must be after this you may get more than one model and see which is having the EIC as a minimum. EIC, those who are familiar with, okay, kind information criteria. So this is one of the criteria to compare the models where the EIC is less, whichever is having less is treated as a good model. So this is the way to good model. Once you get that, once you have built the model, try to do the self prediction and see that for which try to do the residual analysis. Okay, and try to see if the residual is good. I'll explain in the few slides what is the meaning of good. And yes, if it is meeting the criteria, that looks good. It means that is your final model. Otherwise, please repeat the steps. In case of auto ARIMA, basically automated things, all these things done automatically, and this gives you the best model, and then you proceed for the forecast. So this is the basic definition of ARIMA, and this is the way ARIMA really works. And see, if you have seen that in case of ARIMA, you have to make the time series stationary. So as soon as you make the time series stationary, what is the meaning of this? See, stationary means basically that time series does not depend upon the time at which it was observed. So here I have given a few of the examples. I will request you that you can pause the video and see that which one is having, which one is time stationary one. And if you observe all of this, probably then you'll see that point B and point G, these two are stationary, remaining are the non-stationary. Non-stationary means basically they have some kind of trend, either up or down or some. So they have some trend. So this is the non-stationary part. Then the question, as I explained, that how to remove the stationary, basically differencing is one of the technique. Sometimes taking a logarithm or transforming to another state also remove the stationary and make it smooth. And there is another technique also for ACF and taking and if you want to figure it out whether the data has become stationary or not, you can definitely do the ADF test. That is the augmented decay Fuller test. There are few models like ARIMA and ARIMA X. We'll see in the code that what these two models are. Okay, and there are a lot of the other models. These are a special kind of model like white noise. This is the term random walk and so on. Other models which probably you might have heard one or other time. Holt's linear trend method, Holt Winters seasonal method. So these are a little bit old, and most of the times ARIMA and ARIMA X works better than this term. So that is why we'll focus on mostly ARIMA and ARIMA X. Once you have got the residual, then we'll do the residual analysis. I hope you recollect in the regression that when you build the regression, then we had done the residual analysis for the regression model as well. So here the few of the characteristic of residual uncorrelated. It means that it should be fully random. There should not be any trend or any shape left. They should be near to the mean 0. It means that both if there is any residual, both plus and minus should be almost equal. Constant variance, again, that it means below, above and below 0, it looks like almost same and normally distributed. That is the fourth point. So these are the few of the characteristic of residual, and if residual follow this, it means you have got very good forecasting model. Few of the times if you have to figure it out whether it is autocorrelated or not, you can definitely take the help of statistics, and one of these is a Portmanteau test. Second one is basically Durbin-Watson test also for the autocorrelation. So yeah, that's all. So that's all for ARIMA and ARIMA X. So let us go ahead and see the code. And thank you for watching this video. See you in the next one.